You know how the entire tech world, everyone, is in a mad dash to build the next ChatGPT? Well, what if I told you one of AI's own godfathers is making a massive billion-dollar bet that they're all running in the wrong direction? Yeah, this is the story of a rebellion happening right at the heart of the AI revolution, and it might just change everything.
That's right. We're talking about Yann LeCun. This is a guy who literally won the Nobel Prize of Computing for his foundational work on AI. And he believes the approach that powers pretty much every major AI system today is a dead end. But he's not just tweeting about it. He's going all in.
And when I say all in, I mean he just raised over $1 billion to build a completely different kind of AI from the ground up. So what on earth is this radical new idea that's worth a 10-figure bet?
To understand this heresy, really, you first have to know who's behind it.
So this is the man, Yann LeCun, one of the legends of the field. His brand new company is called Advanced Machine Intelligence, or AMI for short, and its goal isn't just to make a chatbot that writes better poems. No, the mission here is to build an AI that actually understands cause and effect in the real, physical world. And get this, it's already valued at a mind-boggling $3.5 billion. To justify that, he's got to solve what he sees as AI's biggest, most fundamental problem.
Okay, so what is this big problem? Well, it all comes down to how today's AI systems actually work under the hood. The vast majority of AI you've ever used, from ChatGPT to Midjourney, it's all based on a method called autoregression. Now that sounds super technical, but the core idea is shockingly simple. At its heart, it's just a glorified, superpowered autocomplete. It's constantly just guessing the next little piece of information, what they call a token, in a long sequence.
Think of it exactly like this. The AI sees a sentence like, "The cat sat on the," and based on the trillions of words it's read from the internet, it calculates that the most probable next word is mat, so it adds mat to the sentence. Then it does the exact same thing for the next word, and the next, one token at a time. Now, for generating language, this works amazingly well, but when you try to apply this logic to the real world, that's where things start to fall apart.
You see, this next token method leads to some huge flaws. First, if it makes one tiny mistake early on, that error can snowball into something completely nonsensical later. This is why AIs hallucinate and just make stuff up. It's not a bug, it's a baked-in feature of the guessing game they're playing. Second, the model has zero real understanding. It doesn't know what a cat is, just that the word cat often appears near the word mat. And finally, it is so inefficient. A video model might burn a ton of energy trying to predict the exact movement of every single leaf on a tree instead of understanding the important thing, which is that a car is about to run a red light.
LeCun put it bluntly. He said these kinds of systems are a dead end on the path to real intelligence. They're useful right now, for sure, but they are not the final answer. So, if that's the problem, what's his big solution?
This is where AMI's whole vision gets really exciting. It's about a huge shift from just predicting language to actually understanding reality itself. This really nails the difference. Current AIs are basically just playing a statistics game, asking, what's the most likely next pixel? AMI wants its AI to ask a totally different question. What is going to happen next, and why? The goal is not just generation, it's understanding. And this entire approach is built on an idea called a world model.
Okay, so a world model doesn't just memorize patterns from data. It actually builds its own internal, simplified simulation of how reality works. It learns that if you drop a ball, it will fall, not because it saw a million videos of falling balls, but because it has actually developed an internal concept of gravity. It's about learning the fundamental rules of the game.
So how in the world do you actually build an AI that can do this? Well, the secret sauce is an architecture with a bit of a funny name.
It's called JEPA. Just forget the complex name for a second. Here's what it does that's so clever. Instead of trying to predict every single one of the millions of pixels in the next frame of a video, JEPA learns to predict a much simpler, abstract idea of what's in that frame. It's the difference between describing a forest leaf by leaf versus just understanding that's a forest. And this is a total game changer for a few reasons. First, it's way more efficient because it's working with small concepts, not gigantic files of pixel data. It also automatically learns to ignore the noise, all the irrelevant stuff, like the lighting in a room changing. And it focuses only on what's important, like a ball flying through the air. And this is the magic part. By doing this, it starts to learn physics and cause and effect all on its own, just by watching the world.
But here's the thing, AMI isn't completely alone on this quest. The race to build these world models is heating up, and it's creating two very different strategies across the industry.
So on one side, you've got the abstraction-first team, led by LeCun and AMI. Their goal is to build an efficient intelligence that can actually run inside a robot, making decisions on the fly. Then on the other side, you've got the pixel-first team, with giants like Google and World Labs. They're using generative AI to build these hyper-realistic simulations, entire virtual worlds, to train their AIs in. So two very different paths, but they're both chasing the same ultimate prize.
So, okay, beyond all the cool tech talk, why does this billion-dollar bet actually matter to you? Well, because its impact is going to be felt in the physical world all around us.
First up, way smarter robots. I mean, imagine a robot that doesn't just follow a pre-programmed path, but can actually understand its environment. It can improvise, it can handle things it's never seen before, and it can operate safely around people because it has a common-sense understanding of physics.
And then there's safer autonomy. Look, self-driving cars need to do more than just recognize a stop sign. They need to be able to predict what a person on the sidewalk might do next. They need to understand that a ball rolling into the street probably means a child is about to run after it. That requires a deep, predictive understanding of the world that today's systems just don't have.
And maybe most importantly, this could lead to truly efficient AI. Because this approach is way less about brute force computation, we could finally see powerful AI that doesn't need a gigantic, power-hungry data center to run. It could live right on your phone, in your car, or in a tiny drone, making smart decisions right there on the device.
So ultimately, LeCun's big bet isn't just about building better tech. It's about a totally different kind of AI, one that's more robust, way safer, and more accessible to everybody. He's trying to build systems that can handle the messiness and chaos of the real world because they actually understand its rules. And by planning to open source their code, they're basically inviting the whole world to help build that future with them.
And that brings us to the final billion-dollar question. Is the next great leap for artificial intelligence really going to come from just making our current language models bigger and bigger? Or will it come from a completely new direction, from finally building machines that don't just talk about our world, but at long last actually understand it?